All right, welcome. Today, we are going to pull back the curtain on the absolutely incredible world of structural engineering. We're going to explore everything from the basic principles that literally hold up our cities, all the way to the brilliant minds who design our skylines, and yeah, we'll even take a peek into the AI-powered future of this essential field.
Just think about that for a second. This quote really nails the massive scale and impact of what these professionals do. We're not just talking about buildings. These are monuments to human ingenuity, and it all begins with the structural engineer.
So, what is actually holding up the world around us? Let's dive right into the core of the discipline that makes everything you see possible.
Okay, so at its heart, structural engineering is all about one thing: making sure the structures we use every single day, from our own homes to massive stadiums, don't fall down. The goals sound simple enough, right? Strength, stability, and durability. But actually achieving all three is an incredibly complex balancing act.
Well, that's where the structural engineer comes in. These are the folks who do the intense calculations, pick exactly the right materials, and design the very skeletons of our world. They make sure that skeleton can handle everything from its own weight to the full, raw power of Mother Nature.
So how does a simple idea on a piece of paper become a towering skyscraper? Well, let's take a look at the engineer's blueprint. And it all kicks off with understanding the invisible forces that are always at play.
You see, every single structure is in a constant battle with invisible forces. You've got dead loads, that's just the building's own weight. Then you have live loads, that's us, the people, the furniture, anything that moves. And then come the really powerful ones: howling winds, the violent shaking of an earthquake, even the crushing weight of heavy snow. The engineer's first and most important job is to account for every single one of them.
And to fight these forces, engineers have a pretty amazing toolkit of materials. Concrete, for example, is an absolute beast when it comes to compression, being squeezed. But steel is the champion of tension, or being pulled apart. Then you have timber, which is a great sustainable option, and these new composite materials are opening up some wild design possibilities. Choosing the right material, that's not just some small detail, it's one of the most critical decisions in the whole project.
And here's the thing: no structure is built in a vacuum. It's a total team sport. The structural engineer works right alongside architects who have the vision and geotechnical engineers who understand the ground underneath the building, and so many others. This collaboration is what makes sure the final building isn't just strong, but it's also functional, sustainable, and, actually buildable.
And this whole collaborative effort follows a really strict step-by-step process. You start by understanding exactly what the client needs. Then you pick the right kind of structural skeleton. After that, you meticulously analyze every single load we just talked about. From there, each beam, each column is designed, double-checked against tough safety codes, and finally, it's all put down in detailed drawings that tell the construction crew exactly what to do. It's a methodical journey from a big idea to a solid reality.
But, this whole field isn't just about formulas and processes, it's about people. So let's talk about a couple of the brilliant minds who took all these rules and used them to completely redefine what was possible, literally changing our skylines forever.
First up, Fazlur Rahman Khan. Seriously, if you have ever stood in a city and just stared up in awe at a super tall skyscraper, you probably have this man to thank. He was a complete game changer. See, before Khan, building really tall was just crazy expensive. The old method used a heavy internal steel frame. The higher you went, the more steel you needed until it just wasn't practical anymore. Khan's genius was something he called the tubular system. He figured out that you could make the exterior of the building act like a strong hollow tube. This pushed the building's loads to the outer walls, which meant they needed way less steel inside. And that single idea is what made super tall icons like Chicago's Willis Tower not just possible but actually affordable to build.
Next, we've got a name pretty much everyone knows: Gustave Eiffel. Now, he's famous for one particular tower, but his real genius was in mastering a material that was pretty new for huge projects back then: iron.
The Eiffel Tower wasn't just some cool monument. It was a statement. It proved to the entire world that an iron lattice structure could be both incredibly strong and shockingly lightweight. And his understanding of how wind actually moves through and around a structure, it was absolutely groundbreaking. His principles are still fundamental to how we design tall buildings today.
So all this history-shaping work isn't just fascinating, it's also a highly respected and in-demand career all over the world. It's a profession that literally builds the world we live in, and that value is recognized everywhere.
And if you look at the career path, you can see a really clear progression. You start out with a good, stable income.
But as you gain experience, that leads to leadership roles and some seriously high-paying opportunities. And for the specialists, the folks who design for earthquake zones or build super tall towers, the earning potential gets even higher.
And that demand is everywhere. You've got hotspots in places with huge construction booms, like the UAE or Qatar, and also in places with super strict safety codes, like the US, Canada, and parts of Europe. For a lot of people, this isn't just a job. It's basically a passport to a global career.
So finally, let's look ahead. Just like almost every other field, structural engineering is going through a massive technological shift, and it's being driven by one major force: artificial intelligence.
But it's so important to see this as a partnership. AI isn't replacing the engineer, it's making them better. It can run thousands of different design simulations in minutes, something a human could never do. It can propose hyper-efficient shapes and forms we would have never even thought of. But the final call, the engineering judgment, the ethical responsibility for people's safety, and that creative spark, that all stays firmly and rightly in human hands.
And that really brings us to the most important point. At the end of the day, it doesn't matter if you're using a slide rule or a sophisticated AI, the core of this job, this responsibility stays exactly the same. It's about using science and creativity not just to build amazing things, but to protect lives, shape our world, and build a safer, more resilient future for all of us.